Hi class, so this is the Unit 1 math review for part 1. This is problems 1 through 5. So let's go ahead and start with number 1. Number 1 talks about the area model of division. So if you need to go back and rewatch my video over the area model for whole number division, it's linked in our module and on my YouTube page. So I'll post that for you if you need it. But let's go ahead and think about this in terms of multiplication. So it says fill in the blanks to complete the area model to solve 800 divided by 25. Well, we know because of the inverse operation of multiplication and division, they undo each other. So 800 divided by 25 is the same as 25 multiplied by some number equals 800. Oops. Let me erase that. That's kind of messy. Equals 800. And similar to long division, the area model is essentially chunking the long division steps. And I'd like to still think of it like my long division house is still there. So I'm going to outline that in red. And before we get started, I know that my divisor is 25. My dividend is 800, and we don't know the quotient yet. So 25 can go into 800, which is the dividend, some number of times. So they already separated out and did the multiplication for you, so it's kind of nice of them. 25 times 30 equals 750. If I'm not sure how to do that in my head, I could always go over and show my scratch work on the side. I know that I'm subtracting 750. I get 50 there. And the partial quotient is the number that the divisor, 25, is being multiplied by, which in this first step of the problem is 30. So 30 goes on top. I have 50 left over after my estimation. And so 50 goes in this box to the right. I know 25 goes into 50 2 times, and they already wrote that out for you. 25 times 2 is exactly 50. 50 take away 50 is 0, which is why there's no other box, because we're done with the problem. The partial quotient for the second box is 2 because the divisor is being multiplied by 2 as the partial quotient. So now I look at the very top and say 30 plus 2, which is adding together my partial quotients, and the final answer, or the result, is 32. And at the very bottom, I'm going to restate the whole thing again. 800 divided by 25 equals 32. For number 2, it says which expressions have the same value as the product of 4/100 times 5 4/10. Circle the letter for all that apply. So essentially, I'm going to be solving this problem, finding my product, or the answer to my multiplication problem, and then I could possibly use mental math to figure out which letters apply. So the first step to this one is solving this problem right here. I know for decimal multiplication that it doesn't matter if my decimals are lined up, because I count the decimal places after the decimal. So my decimal places are counted up. So let me show you what I mean. So 5 4/10 times 4/100. I'm going to use a different color and underline the decimal place value. So we have 1, 2, 3. That means at the very end of me multiplying like normal, that I am going to count back 3 decimal places. So as we're multiplying, we ignore the decimal. We multiply like normal. So I have 4 times 4. I'm going to use a different color. 4 times 4 gives me 16. Carry the 1. 4 times 5 is 20 plus 1 is 21. And then I'm shifting over to my tens, so I'm putting a 0 here. 0 times 4 is 0. 0 times 5 is 0. We add together our partial products, and we get 216. And right now it's a whole number, but if I remember from the beginning of my problem, I have 3 decimal place values. So I move my decimal 1, 2, 3 times. So my answer to that one is 216 thousandths. So now I need to figure out which of the letters equal 216 thousandths. So I can do these ones in my head because I'm just going to be moving a couple of place values, because all of my numbers are 216 in some form or another multiplied by a power of 10. So if I multiply 21 and 6/10 times 1/10, am I getting smaller or am I getting bigger? So I'm going to be getting bigger, which means that I move over one place to the right. So this is going to equal 2 and, oops, that's my decimal, 2 and 16 hundredths. So that's not going to be it. So A is not correct. This one, I'm moving my decimal place 2 times to the left. If I do that, then I get 216 10,000ths, which is still not equal to 216 thousandths. So that 0 in front makes it not equal. So that one's not going to be it. I have 2 and 16 hundredths times 1/100th. So I'm moving my decimal place 2 times again, and I get the same exact answer. And I know that can't be correct. For D, I have 2 and 16 hundredths times 1/10, which means I move my decimal place over one spot. And this one, my friends, is correct. That one gives me the same value as the product. And so I would pick D. Let's do E just to make sure. So whenever we have a whole number, 216, like we have in E, the decimal is invisible at the very end right there. And I know that I'm moving my decimal place 2 spots. 1, 2. And so this one's not going to be it either, because this one gives me 2 and 16 hundredths. So D is the correct answer for number 2. For problem number 3, we're adding and subtracting decimals, so this is where it really matters that our decimals are lined up. And as frustrating as it might be to you, you need to make sure you solve each letter. So we're solving for A, B, C, and D. So let's get started. Let's solve for A first. So we have 24 and 2 hundredths plus 35 and 60 hundredths. And we drop the decimal down immediately before we start adding like normal. So we have 2, we have 6, we have 9, oops, and we have 5. So is 24 and 2 hundredths plus 35 and 60 hundredths equal to 59 and 8/10? Well, we just solved over here, and no, it's not true. So we are writing false. Okay, so I'm going to change color so I don't confuse you with my scratch work. So I'm going to change to green for part B. So I have 74 and 93 hundredths minus 28 and 35 hundredths plus 34 and 6/10 equals 12 and 8 hundredths. So whenever we do this, we need to make sure we solve for what's in parentheses first. So I'm going to add this up, and then I'll do the second step later. So for B, I'm going to add what's in my parentheses. So I have 28 and 35 hundredths plus 34 and 6 tenths. And if you want, you can add a placeholder here because it does not change the value and it might be easier visually for you to add. Okay, and a reminder that we're adding, so we drop the decimal down before we start adding. So we get 5 plus 0 is 5, 6 plus 3 is 9, 8 plus 4 is 12, carry the 1 to the tens place, and then we get 3 plus 2 plus 1 is 6. So we're not done yet because we have to subtract. So we got this as our answer to the addition problem, and now we have to take our answer and subtract it from 74 and 93 hundredths. Okay, so subtract, and whenever we subtract, we have to make sure we drop our decimal down as well. So I can't take 5 from 3, so I need to borrow. That becomes an 8, and this becomes a 13. 13 minus 5, it gives me 8. 8 minus 9, I can't do it, so we have to borrow again. So that becomes a 3. And this becomes an 18. I know 18 minus 9 is 9. I have my decimal, and then I have 3 minus 2 is 1, and then 7 minus 6 is 1. So my final answer is 11 and 98 hundredths. That is not 12 and 8 hundredths, so that is also false. Okay, now I'm changing my color to blue, and let's solve for C. So similar to the B, I'm going to solve for what's in the parentheses first, and I'm going to solve that in the bottom left corner over here. So whenever we're adding the decimal, or adding the decimals, we have to make sure that we line them up. So 16 and 15 hundredths plus 23 and 23 hundredths. Okay, drop down my decimal first. 5 plus 3 is 8. 1 plus 2 is 3. 6 plus 3 is 9. And then 2 plus 1 is 3. I'm not done solving though because I have to subtract it from 47 and 4 tenths. So 47 4 tenths minus 39 and 38 hundredths, and I'm going to add my placeholder as a 0 because it does not change the value and it's easier for me to see it visually. So I know I cannot, I dropped down my decimal. It's always good to do that first. I can't take 8 from 0, but I can borrow and make this 4 a 3. The 0 becomes a 10. 10 minus 8 is 2. 3 minus 3 is 0. Can't take 9 from 7, so I borrow again. And the 7 becomes a 17. The 4 becomes a 3. 17 minus 9 is 8. And then 3 minus 3 is 0. So this one is true because it is 8 and 2 hundredths. And for the last one, I'm going to use purple. So for part D, we're just subtracting. So just one step here. Feels like we've been doing this problem forever. So we have 925 and 1/10 minus 81 and 63 hundredths. So I'm going to drop my decimal down first, add my placeholder so it's easier for me to do this visually, and then subtract like normal. I can't take 3 from 0, so I have to borrow. This becomes a 0, and this becomes a 10. 10 minus 3 is 7. Can't take 6 from 0, so I have to borrow. And this becomes a 10. So 10 minus 6 is 4. 4 minus 1 is 3. And I can't take 8 from 2, so I need to borrow again. The 9 becomes an 8. The 2 becomes a 12. 12 minus 8 is 4. 8 minus nothing is 8. And so this one is also true. So for number 3, you should have gotten false, false, true, true. For this problem, this is an example of expanded form. So I'm going to make this a little visually easier for myself, and I'm going to add the parentheses around the representations of my place value. The place values are represented by powers of 10. So we have 1,000, 100, we have 1/10, and 1,000. Oop, it's going into my 5 there. And we have 1,000th. Okay, so which decimal represents 4,000? So 4 times 1,000 is 4,000. 9 times 100 is 900. 2 times 1/10 is 2/10, which is represented like this, 0.2 or 2/10. And my last section is 5 times 1,000th, and that's 5,000ths. So 5,000ths is written like this. So you could do this a bunch of different ways. You could do this in your head. You could line up the decimals and add like normal. But I know that if I were to say 4,000 plus 900, that's 4,900. And then there's a decimal. I have 2/10, I have no hundredths, and I have 5,000. So the correct answer would be B for this one. And if you have a place value chart, that might help you, but the answer to number 4 is B. This last problem has 2 parts, so let's work on part A before we work on part B. A baseball team practices 4 times a week. Each practice lasts for 115 minutes. The team practiced for 12 weeks during the season. So we're trying to figure out how many minutes did the team practice during the season. So I know that they practice 4 times a week for 115 minutes. So 4 times a week times 115 minutes, that's already one part of my problem. 4 times 115, and there's 12 weeks. So whatever I get as my answer here, I need to multiply that by 12. I know that 12 times 4 equals 36. So I'm going to simplify this for myself and just do one big problem. And you could do this a different way. This is just how I'm doing it. So 36 times 115. And I'm going to reset my problem at the bottom. So 115 times 36. I get 6 times 5 is 30. Carry the 3. 6 times 1 is 6, plus 3 is 9. 6 times 1 is 6. I'm shifting over to my 10s, so I need to put a 0 in my 1s as a placeholder. I'm also going to erase the 3 so I don't get confused. So 5 times 3 is 15. Carry the 1. 3 times 1 is 3, plus 1 is 4. And then 3 times 1 is just 3. And if I add these two numbers together, I get 0. 9 plus 5 is 14. Carry that 1. 6 plus 1 is 7, plus 4 is 11. Carry that 1, and I get 4. And make sure you add the unit. So how many minutes did the team practice during the season? The team practiced 4,140 minutes. And that's the answer to number 5, part A. Let's work on part B. So for this one, you have to know what we just did for part A. So I'll remind you what our answer was in just a moment. Let's read the question. How many hours did the team practice during the season? Hint, remember that there are 60 minutes in 1 hour. So if we had in our part A 4,140 minutes, and we're trying to figure out how many hours, we need to divide this by 60. The number of minutes divided by 60 will tell me how many hours they practiced. You can use any method you want for this. I'm going to use long division. So my divisor goes on the outside of my division house. And there's no decimal. It's at the very, very end. So you could put a decimal at the very end of the quotient, but it's a whole number, so you don't need to worry about decimals. This is a comma, don't get that confused. So I know 60 cannot go into 4, 60 can't go into 41, 60 can go into 414. I'm going to guess and check to the side. I know that 6 times 4 is 24, so 60 times 4 will give me 240. We could probably go a little higher than that. I'm going to try 60 times 7 and see what we get. 7 times 0 is 0. 6 times 7 is 42. Oh, we're a little bit too high, so let's try one lower. So 60 times 6, I get 0, I get 36. So I have 60 times 6 is 360. I'm going to stick with that one. So I'm putting the 6 here for the first part of my quotient. 6 times 60 is 360. I subtract. 4 minus 0 is 4. That becomes an 11. This becomes a 3. So 11 minus 6 is 5. And then 3 minus 3 is 0. And then I bring down my 0. So I'm going to try my guess and check method again. So I know my number is going to have to be higher than 7. So let's do 60 times 9. Let's see what happens. 9 times 0 is 0. 9 times 6 is 54. And would you look at that? It is exactly right. So 9 times 60 is 540. We subtract. We get 0, which means that we are done. And my quotient is 69. And it's asking how many hours. So I'm going to be polite and write 69 hours. And I'm going to circle my answer so that my teacher does not get confused and that I don't get confused. So they practice for 69 hours.